Okay, I think that was the go to start. Okay, so I'm going to talk about deploying Haskell into production, which was sort of a scary and impossible seeming topic for me for a long time, which is why when I sort of finally felt like I had it nailed, it was something I really wanted to share. Oh, really? You're immediately gonna... What? Oh, my slide clicker doesn't want to go. Oh, I turned it off. I'm a fool. Okay. So the takeaways that I really want people to get from this is that Haskell is totally something that you can use on servers. And that choosing to use NixOS can take all the pain out of that. Well, all is a strong word. I'm actually going to be apologizing for a lot of aspects of Nix today. As some people can vouch for, I can't solve all of your Nix problems. And that the code that I'm going to give you is really all that you need to actually be able to launch things in. I always hesitate to use the word turnkey to describe everything, but Nix has given me the most turnkey solutions to anything that I've ever seen. So I'm going to hope everyone has some general Linux familiarity here and understands kind of what we're going to be doing, just in terms of running processes and web server. And I wrote this actually before I came here, and so now that I'm here, I can see I probably don't need to run through these prerequisites because everyone is not quite so beginners, are we? Okay, so quick outline. First, we're going to talk about what Nix is, because I think there's a lot of confusion around that, because it's kind of unlike any other thing. It's not a direct alternative to anything else specific. I'm gonna talk about launching on EC2, the Amazon cloud, just because that's what I'm familiar with. This isn't really going to be a course on EC2 exactly, but I wanted to give some concrete example, and that's what I've done. The particular build process that I'm going to recommend here is you will build NixOS locally on your machine and then upload it onto your servers. And then so we're also going to be using Nix in addition to just for deploying. We're going to be use it for building and creating a build environment. And so if you're, for instance, using Stack, this might replace that. So the advantage you'll see here is that if you use the same sort of tools in your development as for deploying, then you end up with more consistent deploys and you know exactly what you're deploying. And then, yeah, who here is familiar with Nix? I should ask. Okay, so not even too many. So then I will need to explain what pinning means when we get there. And then how about systemd? Has everyone at least heard of systemd? No? Yes? Okay, well, we'll talk about what that means.
I've seen people fighting about it on Twitter.
Right. I'm not going to opine on systemd at all. It's what NixOS uses. It's what I'm familiar with. I'm not going to engage on whether it is good or bad. Okay, and then as our example server, we're going to be using a basic web server, and I'll show you the Scotty library, using reverse proxying with the Nginx server, which is a common thing, but again, I'll explain it if we haven't seen it. And then go into a fancy systemd feature called socket activation, and then finally we'll look at logging, because I think logging is an example of a place where Haskell really shines on servers, in that every other language ecosystem has a really complicated logging story, and I think you can make it exceptionally simple in Haskell. I'm not going to be talking about serverless architecture at all. I hope you went to the serverless Azure talk if you wanted that. Personally, I really like thinking about individual servers, and my opinion is that you really need an understanding of individual servers, and to really nail that aspect of it, before you then talk about then scaling up into a ton of servers. You really need to understand what's going on at the server level. I'm not going to touch on Docker at all because I don't really know anything about it. And we'll see that Nix kind of serves as a substitute for some of the things Docker does anyway. And like I said, this isn't going to go too heavily into AWS details. I'm not also, a lot of times when people are talking about servers, they're talking about eking out every little bit of performance out of their servers. That's not going to be my focus either. And then those of you who are familiar with Nix might know that recently Nix 2.0 came out, which introduces a single sort of command line tool called Nix that kind of is eventually intended to replace all the command line tools I'll be talking about today. But since I'm not particularly familiar with that yet, and since it's not quite finished yet, we're just going to pretend that doesn't exist. OK, so a quick history of me to kind of motivate this. In the early days, I was deploying PHP and then spent a good number of years in the Java mines. And then somebody convinced me that Python was the language that you want to use if you're starting a company and deploying stuff on servers. After putting in a couple of years of putting up with that, I finally felt like I really needed to move on to Haskell. And NixOS came around at a perfect time because it was really what I needed to be able to deploy that Haskell. Because until then, I feel like the deploy story for Haskell was actually kind of bad. It's funny because PHP sort of has the best story among all of these, right? Back in the day, what was that, 2003? Life was simpler, right? You could just drop your PHP files onto your web host, and then you would have a web server, and it was pretty amazing. And Java also sort of had an answer, right, for web servers at least. They had the servlet containers, where they told you exactly what to build. You got a WAR file, you dropped it onto your server, and then it was running. I had a harder time with Python because there are a lot more things with native dependencies. We had to kind of ship a rec file up to the server and then build a virtual end maybe, and had some contrived things around that. So enter Nix, which, as I said, it's still rough around the edges, but promises to really solve a lot of these things. So Nix showed up in 2006, really. Elke Dalstra's PhD thesis was about this and introduced most of the concepts that haven't really changed to this day. It's just been gradually getting more and more polished over the last decade or so. So these are quotes from his PhD thesis, where he says, it's about getting programs from one computer to another and having them work when they still get there. And I very much agree with him that this ought to be a simple problem. Right? We ought to know what files. All we want to do when we talk about deploying servers, really, is I should know what files I want to be on the server. I need to make something happen to produce those files and to get them there. However, in practice, portability can be really tricky. A lot of times we don't even understand when we've compiled something what the ramifications are, what the details are of what we've compiled. Does it have these runtime dependencies? Does it have dynamically loaded libraries? I still can't even honestly say I can explain what a dynamic loader is, other than that sometimes it causes my programs to not work when it's not in the right place. More simply, we've probably all directly seen when a program is going to fork and call another program that needs to be on the binary path somewhere. And then furthermore, it's a transitive problem, right? So my dependencies are also going to have dependencies. So it's not even enough really to understand my own software in depth. I have to understand the world. So Elke says in his thesis that the main idea here is to store all the software components in isolation from each other in a central store. And we call this the Nix store because the path is literally at the root of your file system /nix/store. And then under that, we have absolutely everything that Nix has built. And the paths here, this jumbled mess, is a cryptographic hash. In this example, it's a path of Firefox. Not of Firefox itself, but of all the components involved in building it. So we have a complete understanding, if we have a complete understanding of everything, all the inputs that went into compiling a package like Firefox. So everything about the compiler, all the environment variables we used, all the programs that we might have used along the way, then taking a hash of that now gives us an identifier for this package that is consistent, that as long as the build instructions were followed faithfully, will always produce the same output. And yeah, so we're very much viewing packages as pure functions from inputs to outputs. And I think this is sort of the reason why there's a lot of Haskell NIX overlap, because I think this pitch really appealed to a lot of us. So yeah, having things be at these hash address paths gives us a lot of interesting things right out of the box. For instance, if I want to install 2 versions of Firefox, that's absolutely fine. They're not going to step on each other's toes, because that binary doesn't live at /usr/bin/Firefox, and I'm not sure which one to put there. They're both going to live at different locations. Okay. This is not a comparison. I'm going to hope everyone's familiar with make, right? This is not a comparison that I see people make a lot, but I think it gives us a really good starting point to understand how NIX is and is not like a sort of traditional build like make. So the things that make calls make targets are pretty roughly analogous to what NIX calls derivations. I still don't really understand where that word derivation is coming from, other than the output is derived from the inputs, so they're sort of emphasizing the functional aspect. So with make, you have a make file that is simply a list of all of your build targets. With NIX, you have the config file, which is written in a lazy lambda calculus, much like Haskell, but with no types, unfortunately.
Not yet.
Not yet. People are working on it. People talk about it a lot, but I haven't seen anything come out of it yet. So the most interesting difference to me in this comparison is that, so with make, we rely on the file timestamps very heavily, right? So I declare what the dependencies are of my build target, and so make, when I try to compile something, can look at the last modified timestamp of the build result and of the dependencies, right? And if any of the build inputs have been modified more recently than the output, make knows that I now have to rebuild this package. With NIX, since it's all based on hashes rather than timestamps, we actually can see, are the build inputs different? Is their content different? And this has a lot of ramifications, so I'll go into in a second. The difference with make is that you really have to specify the specific path of the build output, right? The target is actually the name of the file I want to produce. And with NIX, I don't actually name the derivations quite in that way. They just sort of go in wherever NIX wants to put them onto the NIX store. Make also forces us to deal with this concept of cleaning. About if we want to get back to our original source file state and get rid of all the generated things, then we have to write this target called clean, which is phony, that deletes all things. And we have to make sure that we get this right, so we don't delete our source files. So in NIX, what you have is something very, very similar to garbage collection. And in fact, there's a lot of parallels you can draw between the NIX store and the heap in a software system. So whenever you build something, it goes into this NIX store, and it kind of sits there until you eventually run nix collect garbage, which will look at all the dependency graphs and clean out things that it knows nothing is referring to anymore, just like any garbage collector. Similarly, they both have mechanisms for decomposing your build descriptions into multiple files. Right? With make files can include other make files. In Nix, we have this concept of importing. Yes, I said the timestamps were the most exciting thing, but I think the external dependencies question is actually the most exciting thing. And you know what? I'll just mention that in the next slide. Okay, so I want to run through a quick example. We're going to talk about a makefile and then talk about a corresponding Nix package. Yeah.
A question about what happens if your build isn't deterministic, like the build, the binaries and stuff include timestamps.
Yes, that is a good question pertaining to Haskell, right? So the question is, what happens if we don't actually have a pure function because our build process was non-deterministic? And the answer is, it is possible to, let me see.
My question is, does the path depend on like the exact content of the binary that is outputted, or is it just the compiler flags and that kind of stuff? Because like the timestamps in the binary can vary, but then the hash would still be the same because all the inputs are the same.
Right. So it is possible, as far as I know, to compile the same package on multiple machines and actually get different binaries that are going to live at the same Nix store path, right? The assumption is that assuming those binaries actually behave identically, then we have a system that is still relatively sane.
Yeah, so you don't need bit-for-bit dependence, a bit-for-bit build and bit-for-bit dependencies.
Right. Do you have a complaint with that? Or?
No, I was just going to ask, if you have a non-deterministic compiler, do the results have different hashes or the same hashes?
Yeah, I think they have the same hash.
Same hash.
Because I'm going to just quote from Elka here that the hash is computed over the inputs. I think when you start having transitive dependencies down the line, then you might end up with different hashes, right? Because if I then use that binary to build another package, I don't recall whether. Actually, I think they would still be the same because I don't think we're actually going to be hashing that binary. I think we're going to go back all the way to the beginning to the top level Nix expression and hash everything there. But don't quote me on that. I could be wrong.
Well, your compiler could produce something wildly different, and that thing would have different dependencies.
I think it doesn't hash in the binary. Like, even the dependency, actually, the hash is also the product of the idea of dependency is not the actual binary, so it's still, the hash doesn't change down the chain.
Yeah. I want to say the hashes don't change because then the caching behavior would be much worse than it is in practice, right? Okay, so in this example, I also want to show off a really cool Haskell package called Diagrams here. Diagrams is a really good just general sort of graphics library for Haskell. And so they have a number of simple examples here. So for my example project build to walk through, I want to take this example here from the site, and this is just a screenshot of that site where they show what the output of the script is, and then they give a script and then a link to download that script. So what I want to do is write a makefile that's just going to download that code and run it and produce that graphic. I think I need to scroll a little bit. Okay, so we know that the first target, conventionally called all, is what's going to be built if we just run the make command. So that'll be a PNG file that we're going to call Hilbert curve. So this source URL was just copied from the website. That's the URL of this literate Haskell file. So our first real target here is called hilbertcurve.lhs. right? It's the source file that we're going to compile. And then our build rule here is running wget on that source URL. And then, actually, if you're wondering what these $signs are, I actually had to look this up because I'm not a makefile expert myself either. The $@ symbol always refers to the name of the target that you're in. And then if you have a single dependency on your target, then $< refers to the first dependency. Don't ask me why. Okay, so we're going to do this in 2 steps. I actually don't remember if the diagrams library can produce a PNG right off the bat, or if we had to go through an SVG, but I'm going through SVG here. So we're going to use the run Haskell command to run the source file, and that'll produce an SVG. And then finally, to convert the SVG to PNG, we'll use the convert command, which comes out of the ImageMagick packet. I don't know, comes out of ImageMagick, the brilliant command line tool for graphics manipulation. Okay, so here we have a roughly analogous thing written as a Nix file. And I'm so close to being able to fit that on the screen. Okay, so the first thing that we saw in the makefile was fetching the source file, right? So we have the same thing, we're referring to the URL here, but we have an additional thing, which is the SHA-256 hash of that file. So what this does is the fetch URL function is a special built-in, or derived very closely from a built-in function in Nix, which will download that URL and then fail the build if the hash of that content is not exactly the hash we gave it. This is because we are really trying to emphasize the repeatability of our builds, right? We want the build with the same inputs to produce the same outputs. So we can't really get a guarantee like that if we're just going to be downloading files willy-nilly, right? Because if the content of that file changed, now all of a sudden I go to build my thing on another machine and I'm going to be building something different. So the best we can do to fix that problem is simply make sure the build fails if what we downloaded wasn't what we expected. And then, so the next thing over here was running our Haskell file, right, using the run Haskell command. And so for this one, we use a function in the Nix library called run command, kind of what it sounds like. So the first argument that we give it is the name of the derivation that we're going to create. This name doesn't really have a lot of practical effect. It's mostly so that you can get better error messages and sort of more sensible path names in Nixstore. And when you're looking at debug output, have a chance of knowing which derivation you're looking at. The second argument is a handful. It's really the second argument is really most of the inputs. There's a lot of things that we can provide here, but the most common one is build inputs. And build inputs is a list of other Nix packages that we want available in the environment when we run the third argument here, which is a bash script that will run to produce the output.
So does this build there is like a noun, it's the inputs to the build, or it's a verb and we're building the inputs?
Oh, yeah, build there is an adjective? No, wait, they're the inputs to this build.
Okay, so it's more like the noun.
Right.
Okay.
So this you can think of this run Haskell command, this process, as the build, right? And this is the list of inputs to that build.
Okay.
And the only input that we need is GHC with the diagrams package. And then we do the exact same thing, run command again. And we run that same convert command to convert that SVG into this PNG. So you'll notice the big difference here is that we are actually being very specific that we need GHC, that we need the diagrams package, that we need ImageMagick. When we ran the makefile, we just had to sort of write that in our README that you need to have these things installed. Whereas if you have Nix installed, then we can simply run nix build on this file, and anything that you don't have will be downloaded automatically. By the way, there will not be a whole lot of interactive stuff to follow along with here, but if you do want to start playing around with Nix, I should show you how to do that. So there is NixOS, which you can run, but there's also Nix, just the package manager, which you can install on any Linux or Mac OS system. The website is a little confusing, so I actually want to show you this partially just to help you navigate it. So up in the top left, we have a number of Nix-related products that all have sort of similar names. And so Nix here is going to refer to the package manager. And if you click the Get Nix button down here, it'll give you a simple curl to bash pipeline. And once you run that, you will have Nix. Okay, so my complaints with the makefile were it didn't help us obtain GHC and ImageMagick at all. If we were to change the rules of the makefile, if we were to change that command, it wouldn't actually trigger a rebuild because it only knows about the file timestamps. It doesn't really know about itself. Make also, if you remember, we had to, for instance, here specify explicitly that this depends on this and this depends on this. Make doesn't check that at all. And so if I were to forget one of these dependencies, then I could easily paint myself into a corner, right? I could easily get into a position where I'm committing a makefile that seems to work to me because maybe I've built it before, right? But then unless I have tested by running a make clean and destroying my cache, I have no guarantees that it actually works for anyone else.
Clean needs to be correct as well.
Yes, which is point 4 here. We had not only is it annoying that we had to write clean ourselves, but we can really hurt ourselves if we either include too much or too little in it. So the reason that I'm really excited about using Nix on servers is we do get this consistency in the build for reasons that I've mentioned. And you get really what was the holy grail of server deployment for me is being able to just deploy a server in one atomic step. And it doesn't matter what's already there. I don't have to think about what to do if a version of the service I want to run is already there and how to modify it from one step to another. And the other exciting thing that just kind of falls out of this is if I screw up a deploy, if I haven't run the garbage collector yet, all the files I deployed last time are still right there. And so I just need to swap out one symlink and run the activate script, and now I'll be running the old working version again. This is, by the way, a reason that I love running it on my laptops, because I don't have to be afraid at all, for instance, while I'm traveling here with one computer, if I want to upgrade NixOS to the next major release. That's not really a very scary thing, because even if I get to a state where my laptop is no longer bootable because there was some horrendous bug in the next NixOS release, all the previous builds are sitting there in my bootloader, and I can just go up and boot into the last version because it's still there. Okay, so that one input for our server or for our laptop conventionally sits at etc nixos configuration.nix. It doesn't have to, and in our case it won't in the system that I'm going to recommend here. But it's important to know that because there's not really another name for it other than your NixOS configuration, so a lot of people will refer to configuration.nix, and you're kind of just supposed to contextually know what that means. So this can contain a lot of stuff, including the list of all the software that you want your users to be able to run on this machine, all the services that you want to run and any configuration values they take, what users you want to have present. This includes normal users and users that run the services. The host name of the machine, the firewall rules, what time zone you're in, even what version of the kernel you want to be running. Okay, so there are, when I set out to find sort of my perfect server deploying solution, I said what I really want, that it feels like it's sort of ridiculous that it doesn't exist, or didn't as far as I knew yet, was just two operations really. Given a config file that specifies what I want my server to look like, I want to A, be able to spin up a new machine that has that configuration, and B, be able to take an existing machine and turn it into one that has that configuration. So this is step A here. On the NixOS homepage, under the NixOS section of it, not the Nix section, we have a very similar looking button to the one that said Get Nix, except this one says Get NixOS. If we click on that and scroll down a bit to the EC2 section, we have an AMI of NixOS that just has a base configuration with very little running on it, and then one for each AWS region. You really don't have to think about AWS regions unless you are a power user who needs to have your business survive hurricanes. So really, everyone around where I live just picks the North Virginia region. I don't think we even know why. It just doesn't matter. So click any of those launch buttons on the right, preferably one on your continent. And then it launches us into this big, scary AWS launch process with 7 steps. I mostly want to run through this to show you the parts of it that you can ignore, because there's a lot of stuff here, but there's really only a couple things you need to tweak.
So don't you do this with Nix as well?
You can do it with Nix.
I think we're getting to that.
I'm not actually going to talk about launching new instances with Nix. Are you referring to Nix Ops or?
I don't know. I guess so.
Like everything else in Ops, there's so many ways to do it, and I'm just going to give you one. I like walking through the GUI with AWS too, because I think it kind of holds your hand a little if you're not an expert with all the options that AWS has. So it skipped us past step 1 directly into step 2 because step 1 was choosing the AMI, and that button already picked one for us and launched us into here. All of my demos and actually my current production server are just the T2 Micro, which is one of the smallest ones. It's just going to have 1 CPU and 1 gigabyte of RAM. And when I gave a demo of this to somebody, this was a quote that I got that was sort of skeptical that we were going to run a real server and it's going to be deploying Haskell with gigabyte of memory. And it's possible I'm going a little too Spartan here, but I really want to take the attitude that if it's not worth running in a gigabyte of memory, then it's just not worth running. And I want to force myself to be able to deploy in an environment like that.
So
yeah,
I'm quite frugal when it comes to spinning up servers, so I have about 10 of these services running on a single T1 micro.
T1?
T2, sorry.
Oh.
Was it T2?
Yeah.
So this one exactly. Is there a way to do that as well?
To have 10...
I have a few services running on the same server, and I'd like to be able to individually update them separately as well.
You...
Can you do that in the exact same way?
Not the exact same way, but you can.
Okay.
Sandbox.
I was going to say simpler than that. So rather than...
Yes.
I think there's a fairly concise answer that I've thought about, but I'm going to have to get back to you afterward on that. It's really... And I see why you want to do that, but really my goal here has been simplicity. I don't want to think about ops at all. And so if being able to deploy the entire server in a single step means I get to do it in a single step, then that's worth it for me, even if I have to restart services or upload them more than I ideally would like to. OK. Step 3 has nothing here that we care about in these options, except for something that we really care about, which is at the very bottom, hidden under a collapsed by default thing called advanced details, and obscurely titled user data. User data is AWS's way of launching pre-configured instances, and what it does depends on which AMI you're launching. NixOS does something incredibly convenient and clever with it, which is that if you paste a NixOS configuration file here, the contents of that configuration.nix, then when the server comes up, it will automatically build that configuration and boot into it. Which means that if I just have a text file that says what I want on my server, I can just walk through this UI, paste it in there, and now my server will be running with the things that I want on it. If I didn't put in anything in the user data field, this is what the configuration.nix file on that machine would look like. I don't even remember what the HVM option does, but it imports this Amazon image.nix, which just contains a lot of defaults for the specific EC2 environment. And if we wanted to look at what that file contains to see what we're importing, the angle brackets here are the Nix syntax for referring to a file path, but specifically referring to a file path based on this first bit, which is a variable. We'll talk about how that works in a minute. I think is this kind of similar to how like C header imports work? OK, so Nix packages is always going to refer to this Git repository on GitHub under the NixOS group called Nix packages. And Nix packages is really an enumeration of how to build all software in the world. It's pretty amazing. For the last several years, it's been listed under GitHub's top 10 pull requests accepted libraries. There's just a ton of activity here, as you can see by the 2,500 open issues. OK, so that file that we're importing by default is here. Again, I don't even know what most of the things do. One of them, for instance, is inside your AWS network, you have a local time server. And so, for instance, it sets up that configuration thing that says that you want to use AWS's time server for NTP. And then, so what goes in this configuration file, or what can go in it, is enumerated in the NixOS options list, which is just a really huge list that is fun to browse through sometimes. So here is something, or at least something very similar to what I usually paste into the user data field. I'm calling it bootstrap.nix because it's the file that we're going to use to bootstrap to initialize. So it's not going to contain a lot of software. It's just going to contain the bare essentials that are enough for me to then do the second deploy step to get all the fancy packages that I want running on it. So what I do is the services.openssh.ports option specifies what ports we want to run an SSH server on. I like to use something other than the standard port 22 so that my log files aren't filled with failed login attempts from botnets. So I just pick a random port number here. And then we need a separate configuration option on the firewall to allow incoming connections on that port. And then another thing that's not essential, but just a preference for me, is to always turn off password authentication in the OpenSSH config. to force everyone to log in with their SSH keys for better security. And then I don't remember if we're going to talk about these next two on a later slide. Setting wheel needs password false means that when somebody runs the sudo command on the server, it's just going to let them sudo without going through the password prompt. This just made our deploy script a lot easier to write, so we don't have to have an interactive process where we sudo. Because we're going to have a script that SSHs into the server and does some stuff. Yeah, and then I'm going to skip over the next trusted users thing for a minute. Okay, so the last bit of the config that we're going to do is called users.users. I don't really know why users is in it twice. I think the top level users is just general stuff related to users, and then users under that is the set of users that we want. So I'm setting up 2 users here, so that when we boot into our machine, our users, Chris and Julie, will be there already waiting for us. Is normal user just sets up some defaults. Normal user is in contrast to system user, which is when we run services, they're going to run as system users. Users that correspond to people are normal users. And normal users need things like a home directory, for instance. And then extra groups lets us specify what. So by default, normal users are also going to belong to the users group. I'm adding wheel here. If for those who aren't familiar, the wheel group specifies what users are allowed to sudo. So this means we're root users because we belong to wheel. Does anyone know why it's called wheel?
Apparently, I saw an article about this recently. There's an expression called the big wheel, which is like the big cheese, kind of. So like people who are like the elites basically get to be the pseudors. That's the original.
Okay.
Okay.
We're in the wheel of cheese. And then finally, the last thing we've gotten to is actually the most important thing in the bootstrapping, which is that it's going to set up our SSH config, or our authorized keys list for our users, so that rather than having to download some kind of key file from AWS that we can use to log into this machine, it's just going to come up already knowing what our SSH public keys are. Step 4 is just going to ask, most importantly, what the size of the disk we want is. I really don't know why this AMI defaults to 3 gigabytes, because 3 gigabytes is not enough. We don't need a ton, but 3 is not really enough. I usually bump it up to 30. It doesn't really affect the pricing very much, so I'm not sure why you would default quite so low. Yeah, step 5 is also irrelevant. And then step 6, I just need to mention, not really relevant to this talk, but since I am sort of recommending AWS here, I would be remiss not to mention that if something's not working on AWS, check your security groups, because you probably forgot to open a port. This is about 50% of my problems, is forgetting security groups. So we're going to launch one here that has, actually that's an old screenshot. It should have the new weird SSH port we used. And then I'm allowing traffic also from port 80 and port 443, because we're going to run web servers. And then the final step here, the sort of normal process for launching an Ec2 instance is AWS is going to prompt you to download a private key that you can use to log into the instance. We can skip over this step entirely because we already set up our authorized keys in the config file. So if we just click proceed without a key pair here, then we'll just skip over that step. So when we eventually want to become complete pros at this, we don't want to be walking through this GUI all the time. We don't have to, but I don't want to do any premature optimization here as far as the process. But when you get to that point, just so that you know this option is available, the AWS command line has the command is called AWS EC2 run instances. And then you specify a whole bunch of command line flags that correspond to all the fields that we just entered through the GUI. So just so that you know that that's possible. Okay, so here's what we're going to do now when we want to deploy services to this machine that we just started. First of all, we need to understand that all of NixOS is just one huge Nix package. And the advantage of Nix packages is that they're really easy to transfer between multiple machines, because that was kind of the entire point of Nix. With the caveat here that the machines have to be running the same platform. So if you build on Darwin, you're not going to be able to upload to Linux unless you go through some Docker build stuff. Is that what you're doing? Oh no, you're not running Darwin, but
I just set the current the system to build on as to Linux somehow. There was something where there is built-in current system that you can.
I thought so maybe. I haven't gotten that to work. So I believe there is a story for if your laptop is running Darwin and you want to follow the strategy I'm outlining here and upload Linux servers. I just don't know it, so I apologize. So what we're going to do is your development machine is going to compile NixOS, all of the files that need to be on your server, and then we're just going to copy them onto the server, and that's our deploy process. So step one is going to use the nix build command, which is just generally the way to say, all right, I have a Nix derivation specification here, and I want to build it, and the result will end up in the Nix store. So the result will end up in our local Nix store, and then we can use the nix copy closure command, which will then copy it onto our server's Nix store, so that all files we had here are now available here. Nix copy closure, the word closure refers to the transitive closure of the Nix package, which means everything that our package refers to and everything our dependencies refer to, and so on. And then step 3 is a couple of commands that we run on the server that I'm just not going to go into because I don't think the details are important to us right now. The important thing to know is that you can run these commands. And that if path is the path of NixOS that you built here and then copied here, and you run these commands, then your server will now be running your new NixOS build. Let's see. Yeah, so I had said that NixOS is a Nix package. And so this is the basics for that Nix package. This is a minimal Nix file that will build a NixOS system. The important thing to understand about this is just that what goes under configuration here between this curly boy and this curly boy is the is the NixOS configuration file. So that corresponds to the configuration.nix that would typically go under etc. There are some shorthands for this data type. It would be lovely if I could show you a data type declaration, but we don't have types, so I just have to sort of hand wave here.
So if you're starting a new, this is where you put the stuff you just pasted in the user data thing.
Yes. Yeah, so this bootstrap.nix that we're importing here is literally, I'm referring to the bootstrap.nix that we pasted in the user data, right? So we will keep that file around, and we will augment it by adding to this import list. So the general format of the configuration is you have imports, which is a list of other Nix files that will all get merged together into one, and config, which specifies the config options that you want this config file to set. So I said before that we're going to use the nix build command. The simplest way to use that is just run nix build and then the name of the file containing the package description. So our server.nix here. So when we run this, it's going to produce a whole ton of build output, downloading files and compiling things that I have elided here. And then it will print the path of the package that it just built. So we can see, as with all packages, it starts with /nix/store, a big hash, then the name of the package. Let's see. And the other side effect that running nix build has is it will produce the symlink called result for your convenience, so that you don't have to copy and paste that path around. And we see the results just points to this nix store path. So if we take a look at what's in that result, it is a directory that contains everything in this Linux distribution, essentially. And a few things should look familiar from the top level directory in Linux. So you've got bin and you've got etc. But a lot of familiar things are going to be missing. For instance, a NixOS system is not going to have a lib directory at all. The other thing that we can note here is that all of these files are owned by root, and their permissions are set so that they're not writable by anyone. And this preserves the integrity of the Nix store, right? All the files in the Nix store really need to have been built by Nix following the proper build script and sitting at the proper hash output path, right? So they set the file permissions there to prevent you from intentionally or unintentionally meddling with that and compromising your build integrity. The other thing that might look unusual about this is you'll see the file timestamps are all December 31st, 1969. This removes, so let's see, when the Nix builder runs a Nix package, when builds a Nix package, it will then take all the files and set all the timestamps to 0. And this kind of helps curtail some of the problem that we mentioned before, where ideally we really don't want to have ways where we can build the same package twice and get slightly different outputs, right? If we had file timestamps doing what file timestamps normally do, every time we built something we would get a different output because it would always be at a slightly different time. And so Nix has just sort of hacked that off and said, look, we're just really not interested in file timestamps, so we're going to 0 them all. If you are serving static web files through a server like Nginx from a Nix package, this is something that you are going to need to look out for, because if you're familiar with how web caching typically works, usually the browser will request a file with an HTTP header that says, hey, only send me this if it's been modified since the last time I downloaded it. So by default, without some workarounds for that, your server here is going to say, well, the last time this file was modified was 1970, so you're good. OK. So, Oh, this is probably a good time for a break.
And it's perfect timing.
Yes.
Yeah.
Okay. Okay, are we ready? Somebody say something affirmative.
Woo!
Thank you. Okay, so now I want to talk about how to actually bring into effect this plan that we talked about. So really, we could throw this together in about 4 lines of bash. I was a little bit concerned about bringing too much Nix to a Haskell conference, and so I wanted to make sure we didn't overload it, and so I really wanted to write this script in Haskell. I mean, I personally made this choice before the talk because I really would much rather write things in Haskell. But so we'll shift gears for a moment. I want to talk about how the stack shebang works, so that you can write these little op scripts that you might normally write in Bash or Python or something in Haskell quite easily. So this is a pretty good standard starting template here. Nix will not even be involved at all. So we're specifying in the shebang that we want to use stack to run this file. Stack has a specific script command that is designed for stuff like this. We do want to specify what stack resolver we're using so that we don't unexpectedly switch package versions the next time we run it. And so I'm going to be using the turtle package, which I guess we're featuring Gabriel Gonzalez fairly heavily today here. So turtle was designed for, I guess it's a pun on shell, designed for things that resemble shell scripts. Oh, I should mention the one very magical thing about the stack script command is that we imported turtle here, you'll notice, but nowhere did we specify that we actually have a dependency on the turtle package. This is because what stack script will do is it will look through all the packages in this stackage release and look for ones that export a turtle module, and will automatically determine what Haskell dependencies our script has. So that's pretty nice.
What's the no-nix pure?
Yes. It was boring, so I didn't mention it. Stack has this sort of Nix integration, right? Where sometimes it'll run things in a Nix shell if you have it turned on in your config in your home directory, and I do. And by default, it will run it in a pure Nix environment, which I think we'll talk about Nix shell a little more to explain what that means, but we'll essentially strip out all the environment variables because Nix is very much into this deterministic build thing, right? And environment variables are scary sources of hidden inputs, right? So no Nix pure is going to turn off that feature, and I'm telling it I don't want to strip out environment variables. So I want to be able to, for instance, call out to programs that are on my path and have it be my path and not the shell path. Is that good enough? Okay. Okay. So I really like to have a main that serves as a high-level overview for the strategy of what the program is going to do. So this one, I have it annotated to exactly mirror the diagram that we wrote before, with the addition of I'm just going to start by reading the path of the server that we're deploying to from a file. But then, to recap, step one here was to build, and the output of running that is going to be the path under Nix store of the thing that we built. Then we're going to upload all the contents of that path recursively to that server. And then we're going to do some magic on the server to make that become the active NixOS configuration. Even in small scripts like this, I find type safety quite important. And so I like to define new types for text, even if I'm only going to use them once. So the ones we're defining here are NixOS, that is the path in the Nix store, and server, which is the address that we're deploying to. I do have this code published on GitHub, and it's slightly different because I had to go through some steps to modify the server type a little bit. I had a lot of difficulty preparing this talk, actually, because doing my last-minute fixes, I found myself completely unable to deploy my servers from the hotel Wi-Fi, which blocks everything except port 80 and 443. So I found myself in the dreadfully ironic situation of not being able to deploy at all to practice my talk about deploying. So in my real code, you'll see two values here. One is the host name, and one will be the port. But in the script, we just have the host name. Okay, so starting us off very simple. This was part of the reason I actually put the server address in a separate file rather than just hard coding it into the script, just because I wanted to be able to start off with something easy. Turtle provides us the input function, where we just give it the name of a path, and it will spit out the contents of that file. So that will return a line. We use the single function to specify that we only want a single line of text to come out of this input. Because I'm not sure what I would want my script to do if you put multiple lines here. So that will just fail if that file doesn't contain just a single line of text. So then we use line to text that just converts it to a text value, wrap it up in our server new type, and then return it. And so that's all getServer does, reading from that server address file. So with the build script, now we're going to be utilizing Turtle's functionality for calling out to other processes. So inproc is the name of this function that we're going to use. And I really don't know the rationale for any of these function names. I don't know why it's called inproc. I assume the proc stands for process.
I think proc is also the system command. The syscall.
Oh, is it actually the name of the syscall, inproc? Okay.
Just proc.
Oh, well, do you know what the I and the N mean?
No, usually if you use system.process, it's just called proc.
Anyway.
Something about reading standard input or
Oh, that probably is it, because we are going to, well, yeah, because this last argument here that we're not providing anything to is lines of standard input to pass into it.
Yeah,
So you're right, that may be what it's referring to. It's a process with some input. Anyway, so the command that we're going to run here is nix build, as we've said. And the arguments are server.nix. That'll specify that we're building. That's the file that I showed you before, right, that contains all of our configuration. And then when you have one other flag here called no outlink, which is, remember when we ran nix build before and I showed you the output and it had that symlink called result that pointed to the path in the next door that contained the result? That is referred to as the outlink. And in this case, I don't really want it. All I really want is the path that it prints. And so the no outlink flag will just prevent it from creating that symlink. And then we do the exact same thing. We take a single line of output, which is the path in the next door. We convert it to text and wrap it up in a new type. And now we have build, which is a shell command that produces a NixOS store path. Upload looks very similar to build in the sense that we just have another turtle command to run a shell. This one is called proc_s, and again, I'm still confused because this one doesn't have in, but it still has that input. So I'm not sure that theory was entirely right. Proc_s is the function for running a command where we don't care about the lines of output that produces. All we care about is running it and failing if it failed. So we're running nix copy closure. We're specifying what server we want to copy to and what path that we're copying. And then the use substitutes, I'm going to pause and drink some water. Use substitutes enables a really cool NixOS feature, or a feature of nix copy closure, I guess, which is that, so a substitute means I'm going to get a package from a different source. So what this means here is that if any of the files that I'm going to upload to the server are available in the main NixOS cache or any cache that the server has set up, then it will see that, hey, I have a better place to get that file from, and it will download it from nixos.org instead of having me upload it to the server. Which, if I'm out in bad Wi-Fi or at home with a bad internet connection, that's going to be way faster downloading from one cloud to another than from my local laptop. So substitutes really speeds up our deploy if we're deploying a lot of content. And if what we're deploying is not our own packages, but something standard that's going to be found in the main package repository. And then activate is, as I've said before, I don't really care to explain what's going on here, but I do want to explain how SSH is working here. So, normally when you run the SSH command, you just give it sort of the address of the server that you want to SSH into, maybe the user that you want to SSH into, and it'll give you a login shell, right? What I didn't know for a long time is you can also just give a string argument to the SSH command, and that will be a bash script that it will just run on the server. So that's what we're going to do here. With the command that we run in this step is SSH, and then the arguments that we gave to the server, and then this command that we want to run on the server. And since I have multiple steps in this command, the command is a multi-line string. And so whenever I want to have a multi-line string in Haskell, I always turn to the neat interpolation package, which I guess we're getting maybe beyond beginner track Haskell at the moment when we're talking about quasi-quotes. But it's a crazy language extension that is essentially, I don't know, I think of it as highly enhanced string literals. This is a quasi-quote here that starts with the bracket and then the name of the quasi-quoter that we're going to use in a pipe, and then it ends with something roughly similar to that but flipped. And then inside, what Haskell AST this turns into is up to the quasi-quoter. So in this case, text is a really simple one that just produces a text value from what's inside there because Haskell doesn't have very good multi-line string literals. So that was the end of that deploy script. And if we run it, we're going to get, again, a bunch of elided build output, a minute or two of waiting, and then some output that doesn't quite indicate to you whether the deploy actually succeeded or failed. I'm gonna do another apologies for the rough edges of Nix here because a warning I should give you if you're going to start using it is you really have to learn to read the build output to figure out whether your build commands actually succeeded or failed, because they're not really good at showing you a hooray or a failure. It's just kind of, I told you what I've done. You can be happy with that or not. Yeah, I think it's a bit like Haskell 5 years ago, maybe. So this is what the successful run of the deploy script looks like. Okay, so now we turn to the question of what is it that we want to deploy. And I'm going to assume that what you want to put on your server is, of course, a web server written in Haskell. Of course, we want to write in Haskell, and I don't know, I guess the web server is just sort of the standard demo. Because no one in the world can get away from having to write web servers, right? So, so we have the build tools question here, and I've spent a lot of the last several weeks trying to come up with a good answer to this question of how should I structure my Haskell project and what tool should I be using? Should I be using Stack? Should I be using the old Cabal, the new Cabal, all the Nix features, what? So first I want to back up and think about what the goals of our of a Haskell project structure ought to be. What do we want to do with it? And there's really two kind of separate things that we want to do. One, we're going to want to be able to compile it as a Nix package in the sort of standard Nix way, where we have our full determinism, and I just view my package as I have source files and a build process and an output package that I can upload into the server. But this is kind of in stark contrast with what you want to support for the development process, because I never really want to run a full compile of my Haskell code as I'm developing it, because that's going to take forever, right? Normally what you're going to do is you're going to run something like stack build, and it's just going to build the modules that have changed. It's going to give you an incremental compile. So if we're going to have one kind of unified Haskell project structure, we're going to want to support it creating an environment in which we can run our kind of normal development tools and not just be building through the Nix package build process all the time. So following the kind of conventional names, the default.nix file is going to be what specifies how we build when we're deploying for the server. And the shell.nix is going to specify what's in our development environment. And these names are a little bit more than convention. Shell.nix is when you run the nix shell command. it will look for a file called shell.nix and use that as the environment. So this is the demo project that we're going to walk through. It is called Monadic Party. Yeah. Not explaining this immediately. Yes, here's another bit of apology. But also something exciting. So about a week ago, I think Susan Potter tweeted something about this develop package function in the Nix packages repository, which is a really convenient way to set up a shell environment for a Haskell project that you're developing. So all you need to do is give it the root of the project, the directory in which all your code lives, where it should be able to find a Cabal file, and any specific versions of packages that you want if you don't want the defaults that Nix is going to provide. And then you should just be able to run Nix shell, and this should work. I had to make a few tweaks to it, though, in order for this to actually specify something that was usable to deploy to the server. So this is sort of my forked version of the develop package function, which, I don't know, probably consider trying to pull a request into the Nix packages repo at some point. So on one hand, it's kind of an apology that sometimes you have to do stuff like this because the build story is not fully worked out. On the other hand, it's kind of exciting because you get to do stuff like this. If the setup that they gave you is not exactly what you want, you can go into the Nix packages repository, and I highly recommend, if you want to learn about Nix, browse the Nix packages repository, because there is just so much Nix code in there and so much stuff to learn from example. So in particular, what I had to do here is somewhat related to, I think, what I was just talking about with Sid here about making sure that we don't deploy more things than we need, which is to make sure we applied some overrides that stripped some things out of the package that we end up building.
There is a library function for this, I think.
There is, but it wasn't exactly the type that I needed, so I had to copy a bit out of it. So in particular, what we're doing here is when we actually build this, we have this post fixup command, which is going to remove some of the output, so that when we compute the transitive closure for what Nix copy closure updates, that doesn't include more things that we don't actually need at runtime. Okay. As for what goes in our shell.nix, this is a very, very basic thing that we might start with. So the shell.nix is typically going to refer to the default.nix. So I start by loading the whole Nix package set, because that was, if you'll recall, that at the top here, that was an argument to this. We needed to, this whole file actually evaluated to a function, and the function's argument is this set with the Nix packages set in it. So we import that whole thing so that we can then pass it to default Nix to call that function. And a shell.nix should evaluate to a Nix derivation, the Nix derivation whose build environment that you want. So when you run Nix shell, you're not going to build the monadic party derivation, but you're going to build everything the monadic party derivation needs so that you can develop in the same sort of environment that that package compiles in. So here I've added some things, though, to make our shell environment nicer, and you can customize this to whatever tools you particularly like to use. In particular, what I've done is I said that I really want to easily support running GHCI and GHCID in this environment. Right, so I want to provide commands that just launch into those in the proper way without you really having to think about them. So rather than just returning monadic party, we're going to return the monadic party environment with some overrides applied. And in particular, what we're going to do is override the build attributes, the build inputs, so that in addition to the build inputs that our default.nix set us up with, we're also going to add some dev tools that we wanted. And those dev tools were defined up here as our party GHCI command and our party GHCID command. Does everybody know what GHCID is, by the way? Who doesn't? Okay. GHCID is really, is it Neil Mitchell's, right? So all it really does is run GHCI reload in a loop, and it watches your source files. So if you just go into a Haskell project and launch GHCID, then as you type in your editor, GHCID will be displaying you the build output and telling you what all the compile errors are. So it's a pretty fantastic alternative to having a full-fledged IDE or something, to just have a terminal open, perpetually giving you your build output. And so the way I constructed those scripts was using another package, or another function that the Nix packages repository provides called writeScriptBin. And all of this, so the first argument to writeScriptBin is the derivation name. Again, remember this is only a mostly not important argument that just indicates what messages you're going to see for debugging and stuff. And the important argument here then is this is the contents of the script that we're writing. So party GHCI is going to end up being a Nix package that contains a shell script that has this content in it. And this will be a very simple shell script that just runs cabal new REPL to open GHCI. And then the GHCID command works the same way. So to use it, we use the Nix shell command. Remember I talked about no Nix pure before in the script, right? Because I didn't want the environment variables to get stripped out. In this case, the shell environment has everything that we need specified, so I do specify the pure flag. And this gives your team members more reproducibility in your build tools and a better assurance that their own personal laptop environments aren't going to affect how this build environment runs. So all their irrelevant environment variables are going to get stripped out, and we're all going to be running the same GHCI. So then we specify --run and then a string, which is the script that we want to run. And once we do that, this will just launch us into GHCI. So I think this is pretty cool. The emphasis here is that if anyone who has Nix installed on their machine should just be able to do a fresh checkout of your code, run that exact command, and everything that needs to build, including GHCI if they don't have it, will build, and then we'll be launched straight into this REPL. I wanted to show you the cabal file to emphasize what a minimal cabal file looks like. Because the default, if you use something like stack new, is going to give you a lot of things that are mostly designed for libraries. And if you really just want to be able to run something and deploy it to a server, this is the minimum amount of cabal file information that you need. So every package needs a name, every package needs a version, and I think 0 is a fine choice as a placeholder if you never plan to version your package. Because if we're never going to release it publicly, then why do we really care? And cabal version and build type just need to be there. I also wanted to opine for a moment on how I structure my Cabal files, in how the library stanza is chunked here, to de-emphasize the things that are less important and emphasize the things that you want to get to more often and want to modify more often. So start off every stanza with just the answer to the question of where do I find the code. So the library, the code for this is going to be in the lib directory. And then these two groups are really the sort of, most of the time this is the only thing you're going to be thinking about in the Cabal file. This is what you're going to come back to and edit all the time, right? You're going to be adding and removing dependencies, and you're going to be adding and removing modules. So I like to emphasize those in their own little blocks separated by white space. And then the options, your GHC flags, you're rarely going to change, and the default language you're never going to think about until 2020, I think, the next Haskell report. Okay, and then I just have an executable, which is very similar. I'm calling this party Scotty because this will be our Scotty demo. And then the only thing to remind you of, if you're not familiar with editing Cabal files, is the common mistake that the executable always has to have a dependency on the library. You would think it would just be sort of implicit, but it's not. Okay, so web servers. Yeah, it's just a quick overview of the kind of web server related package ecosystem for Haskell. And these are ordered from kind of less complex or more fundamental things to more complicated things. So HTTP types and cookies, for instance, are not frameworks at all, not servers. They're just sort of utilities, right? Functions related to how to parse cookies, what the type of an HTTP request is, and so on. Then WAAI stands for the Web Application Interface Framework, I think. Sure. And then WARP is the implementation of that. Both of those, if I recall, are Michael Snowman products, right? I don't know of any Haskell web servers that aren't based on WARP in WAAI. I don't. Maybe someone has heard of another one, but as far as I know, the entire Haskell web ecosystem has converged on WARP. It took me a long time to notice this because I never really watched Star Trek, but Warp, Scotty, and Spock are apparently all.
Oh dear.
So WAAI gives you a very minimal interface for defining a web server, and if you're doing something very basic, it might be enough, but it doesn't have a lot of niceties. Scotty adds a lot of those niceties. It's still not really a full web application framework, but at least it has these concepts of kind of routing and more friendly functions that deal with, for instance, the text type instead of low-level byte strings. Spock might be on par with Scotty in terms of complexity, but I think it's a little more fully featured. And then I really know nothing about Servant and Yesod other than that they sound kind of crazy in terms of their scope. So we're using Scotty because I think it hits kind of a sweet spot in the middle as far as features and not being too complicated. I don't know why I put the imports on the slide. So the basic way that you use Scotty then is you define, there are two primary monads for Scotty. One is Scotty M, which is here, and one is action M, not pictured, but it is the value of this, starting from after the $sign. This is of the type action M. So Scotty M is how you define the entire application. It's how you piece together the routes that will form your whole web server. And then action M specifies what I do when that particular route gets run, how I handle each request. So I have a very, very basic demo here. Inside the Scotty monad, we specify that when you have a GET request, at the URL/Scotty, then I'm going to run this action. And all the action says is return HTML that is this text. And again, I'm using neat interpolation so that I can get those nice multi-line strings. And then all we have to do in our main is run the Scotty function, tell it what port we want to serve on, and what Scotty application we want to run. So now how do we integrate this into our NixOS configuration? We're going to do this by continually expanding upon our server.nix file. So I've added some things here. We still have Bootstrap before. And the reason I'm keeping Bootstrap as an import here rather than modifying it is that we want to keep it around unmodified so that when we launch new servers, we can still have it. Because we don't want to launch a ton of software when we first launch our server because we want it to just come up quickly. And also that user data mechanism doesn't give us a way to specify multiple files. So if we started building off an NixOS configuration for our bootstrapped instances that had imports, we wouldn't actually have any way to copy it into user data. So I'm going to add a module here for our Scotty demo, and I'm also going to add one for Nginx because the typical way of running a web server, right, is you always put Nginx or something minimal and speedy in front and then reverse proxy to your actual application server. So we are running Scotty import 8000, and then Nginx is actually going to do the front end stuff. And later we're going to see we're actually going to add HTTPS, so Nginx will be in charge of the TLS and everything, so we don't have to do that in Haskell. Okay, so now we're getting into the question of how do you define services in NixOS. So that's the content of that Scotty module, party Scotty. Okay, so much like users.users was an object that contained all of the users that we wanted our system to have, systemd.services is an object that contains all of the systemd units that we want our service to have. Oh, and then I should back up and talk about systemd, since I think we had some people who didn't necessarily know about that, right? So systemd is called your init process in Linux. It has pib 0. It is the first thing that launches when your machine starts, and it is in charge of running everything else. So it's there are some other things in its purview as well, but the takeaway here is if that I want some background process to be running, the easiest way to do that is to tell the systemd configuration, hey, among your other jobs, I would like you to also run my service, and this is what it looks like, and this is how you run it. And some other things about how to run it too, right? Like in the configuration here, we say that when do I want you to ever restart my service? Well, only if it fails, only if it terminates with an exit condition that's not 0. Then systemd will restart our process for us. So when we run our server, we don't even have to think about necessarily handling exceptions perfectly to make sure that our daemon stays up all the time. If we crash systemd, we'll just start us back up again. We specified that it is wanted by the multi-user target, and wanted by means, so systemd has this whole graph of services that depend on each other, and that determines when some of them start. Because systemd will also manage your entire boot process, right? And so some of the things as you're just bootstrapping the machine as it's loading. So that includes some of the things that happen at the low level before the multi-user environment even gets turned on. The short takeaway from this is that wanted by multi-user is the really common thing that you're going to want to put in all your services. So that specifies that tells systemd that when it's time to bring up the multi-user environment, the sort of normal operating environment, once everything in the computer has been loaded, I want my service to be included among those things. Environment specifies just environment variables that are going to be available when we run this command. And this is another annoyance that shows up really only when you're using Nix, interestingly, because there's a lot of dependencies that your software has that you don't know about it until you're running it in a clean Nix environment. For instance, if I'm running a service on Ubuntu, I probably have these environment variables set that my locale is specified to. Well, it doesn't have to be English US, but it probably needs to be UTF-8 if you want your program to support UTF-8. And a ton of Haskell programs have this problem because a lot of the standard library things, when they read text from a stream, will use that stream's default encoding. And unless something has set that encoding to be UTF-8, you're probably going to be reading ASCII, and you probably don't even know it. So this is a really common reason why when you try to take some code that you're running in Ubuntu or something and move it into NixOS, and you get weird encoding failures, it's because we had to do a few more things manually, or there's a few more things that we didn't just get out of the box. Because maybe we didn't want the locale to be set to UTF-8. But in practice, we do. So really, all your systemd units are going to want to have something like this. And then the most important thing here I've left for last, which is the exec start in the systemd unit is the command that we're going to run to launch our server. And so we do this by... Man, I really should probably explain some of the syntax here. Inside a string literal, Nix has string interpolation, and that's what the $sign and curly braces are. So starting from here to here, we are actually it's called an anti-quote. So this stuff is string inside the string literal. Right? This stuff is a Nix expression. So we're going to import this, and when we import a directory, it's actually importing the default.nix directory inside. So remember I said shell.nix has a special meaning to Nix shell. The file name default.nix has a special meaning when you're importing.
We have to create the user anyway.
We do have to create the user, yes. In fact, did I do that here? No, I didn't. Ooh, I might have been bad. I might have left the user creation out of my slides. But yeah, we saw how we did that before, right?
Yeah, I've seen. I've checked on the slide.
Okay. Yeah, so it was the same way as way up before in our Bootstrap file when we created said users.users.chris, and then we had all that, including our authorized keys file, right?
You could imagine that actually like systemd module can create users, for you.
Systemd does support.
Would be hard,
Systemd does support that. You can add dynamic user is name, and systemd will create the user for you.
That's
quite handy. This one bent and look at that. That's nice.
So I don't know if the Nix module supports like passing that flag on to the systemd server.
I don't know. I also don't know why you would necessarily want to choose one or the other. Right, because NixOS can also create the user for you, right? Yeah. So that is good to know now. So yeah, adding the user to the NixOS configuration is just a one-liner because we don't actually need to give it any configuration. We'll just say, what was the name of the user we specified? Yeah, so we would say users.users.monadicParty equals an empty object, just curly braces with nothing in them. And then we will just magically have a user by that name. Okay, so anyway, what was inside of this this anti-quote here? So this will evaluate to a Nix package, or a Nix derivation, which when it's used in the context of a string here, will end up getting coerced into a string by just turning it into its store path. So it will build this. This will end up resolving to /nix/store/ a big hash. And then under that is a directory called bin and the executable that got created that was called Party Scotty. And then the other bit of Nix configuration that we needed was to set up Nginx to reverse proxy to it. Oh man, this is a lot to go through, but NixOS does a lot for you, because normally Nginx config files are a huge bag of worms. That's not an idiom. And there may be an annoying large amount of configuration here, but it is a lot less than you would write if you were actually writing the Nginx config file yourself. So you're writing Nix config, and when Nix generates this package, it will generate the Nginx config file. Well, in addition to that, we've also added some firewall rules here to specify that we want 80 and 443 open. It has these really convenient things, which will just sort of turn on a lot of really good defaults for Nginx. And then we specify that under the location Scotty, so anytime Nginx receives an HTTP request that starts with /Scotty, we just want to pass that request off to our local server that was running on port 8000. And then the fantastic bit of magic here that I realize we're probably all tired and ready to go home pretty soon. But if I could grasp your excitement for a moment at how amazing the Acme feature is. So we add these 2 lines of config to this file, and now we automatically have an SSL cert, and we're serving HTTPS.
Yeah.
Yes,
Let's encrypt.
this is the magic of Let's Encrypt. Yes, so the Acme is the name of the service that automatically handles the stuff that makes Let's Encrypt work. So what Let's Encrypt is a certificate provider that runs automatically and for free. So unless you have special needs, stop buying SSL certs, please. You can just generate them with Let's Encrypt. And so all it will do is make an initial request to your web server to verify that you are the owner. I don't even remember how the details work because I sort of forgot about it because I don't need to.
So you have like a DNS
You have multiple challenges. There is like 3 different ways you can verify your.
My bet here would be that's actually like
It's
acting for like an endpoint, and then it's actually getting this getting a request to an endpoint to verify that under the server. It's supposed to be answering in a given way. And
Don't know the details, but Let's Encrypt is a fairly well-trusted certificate provider. It seems to have been working fine for me so far, so I'm just going to be happy with it. Anyway, now that we have our magic SSL, I think that might be a good time to adjourn for the day. Oh, and in case you haven't noticed, sorry, I have set all of this up on a server. You can look at my slides and my code at monadicparty.chrismartin.org. Just to prove to you all that I am in fact eating my own dog food and running all of this for real.